All right, so this says the length of pregnancies in a small rural village are normally distributed with a mean of 265, standard deviation of 17. The distribution of values is normal with a mean of 265, and they just repeated themselves. Okay, what percentage of pregnancies last fewer than 250 days? So just draw a quick normal curve. Do this every time. Put the mean in the middle, 265. So I want to know what percent lasts less than 250. I'm looking for that. So in our calculator, that's going to be just a normal CDF. My lower bound is some really negative number. I'm just going to do negative 100,000. My upper bound is 250. My mean is 265. And my standard deviation is 17. So we get 1.1887. Now it wants it written as a decimal. You have a decimal symbol here. This is not a decimal. So if you rounded this to one decimal place, this wouldn't be correct. So you have to move this place 2 places over, which is 18.87. Rounded to one decimal place would be 18.9. Okay. Next one. Town of Nowhere Special, USA operates a rubbish waste disposal facility that's overloaded up to 4,861 households, discards waste, with waste having a mean that exceed 27.11 pounds per week. For many different weeks, it is found that the samples of 4,861 houses have weights that are normally distributed with a mean of 26.69, standard deviation of 12.24. Sample. Sample is the key word. That means we're going to change our sigma. All right, so you can draw your curve again. The average or the mean is 26.69. My sigma now, though, is going to be 12.24 over the standard deviation of 4,861, the size of the sample. I want to find the proportion of weeks in which the waste disposal facility is overloaded. So I just want to know what's the area above 27.11. So again, we're going to go to normal distribution. My lower bound now is 27.11. Upper bound is going to be a big number. Mean is 26.69. And my sigma, I'm just going to write this the way it is. 12.24 divided by the square root of 4861. So I got 0.0083, but to 4 decimal places. Let's just see that again. 0.00836, so 0.0084. And the last one, combined SAT scores for students at the local high school are normally distributed with a mean of 15 standard deviation. So this is the college includes a minimum score of 657. Same thing. We're trying to find the probability of being larger than that. Normal distribution. My lower bound, because I'm looking for x to be higher, is 657. Upper bound is going to be a big number. My mean is 1536. Standard deviation is 293. Paste. We get 0.998, but it wants one decimal place. So 0.9986. Well, this would be 7. I'll leave it at 6.5. This is not a decimal. This is not a percent I mean. You have a percent symbol here. So I have to change this to a percent. So this is 99.86. So the one decimal place would be 99.9.